Continue with the first part of quantum numbers. We had discussed in the first part principal quantum number, that is denoted by n. Now let us move to the second quantum number, that is called azimuthal or angular momentum quantum number. Now it is denoted by symbol L. It represents number of subshells in given shell, or we can say the given value of n, how many subshells are there, that is kind of using this quantum number, that is L is there. Now is L value can be 0, 1, 2, 3, 4 and so on. So for these we designate, if L is 0 then we say it is S subshell, then P, D, F, G is there, but till now there are only these subshells. So S subshell is there, spectrum, principal, diffuse, fundamental. These are the historical words from where it is taken, like S for spectrum. From spectrum word we have taken S, principal P, diffuse D and fundamental F. So these are the subshells given, and these subshells they have a different shape. Like if I move to this one, you can see S subshell they have a this shape, P has this subshells, these are the shapes, right? And in D it will be different, F also. So these orbitals, these subshells have a different shape. Like S subshell, it has a spherical shape. It is like this, three-dimensional region is there. So anywhere in this region electron can be found. Of course size can be different. If it is present in first shell, then the size will be small. If it is present in second shell, then obviously the size will be bigger of that. And similarly for P, it has a dumbbell shape. So dumbbells use करते हैं weight के लिए. Okay. So it is like this one lobe and there is another lobe is there, course of same size. Here it is just they are meeting, intersection point is there. So these are the lobes, two lobes are there, dumbbells. And D, it consists of double dumbbells. First one is there which has a little bit different shape. So usually it consists of two dumbbells. And then different system. So main thing is that L it represent the N represent the shell, and within the shell there are subshells. These are represented by L. Now values of this also, of course, it can represent the energy also, like in 1s, 2s, 2p, the different energies can be attained in this. Now value of L, it depends upon the N, and L can have values from 0 to N minus 1. Or in other words, we can say that number of subshells in given shell is equal to N. Right? If N is equal to 1, means number of subshells also will be 1. If N is 2, then number of subshells will be 2. So number of subshells in given shell, that is जितना N की वैल्यू है वही उसकी subshells उतनी ही होंगी. बट जो वैल्यूज वो अटेन करेगा that is 0 to N minus 1. Say if it is N is equal to 1, then value of L तो होगी 0. Now highest value n की 1 minus 1 0, so it is only one value, that is S subshell. So for 0 we say that it is S subshell, but कौन सी shell में present है? First में, so इसको हम designate करेंगे by 1S subshell. Similarly for n is equal to 2, एक तो वैल्यू होगी 0, अब उसके बाद नेक्स्ट वैल्यू क्या आएगी? n की वैल्यू पुट करोगे 2 minus 1, so it is 1. So there are two subshells present. Now 0 second shell में है, तो L वैल्यू 0 है तो we assign S, so it is 2S, 1 है तो 2P. Similarly if we take n3, तो L की वैल्यूज क्या हो जाएंगी? 0, 1 and 2, so it is 3S, 3P and 3P. So from L we can find out the number of subshells in given shell. Then next quantum number is magnetic quantum number. Now magnetic quantum number, it is represented by small m and at the base it is usually written as L. Now it represents the number of orbitals in given subshell. In subshell, there could be different regions there, in different directions there, so orientations are there in different direction. So we say the number of orbitals in that. Now its value depends upon the L value. It varies from minus L, 0 to plus L, और जो total values होंगी m की, that is equal to 2L plus 1. So for example, if we take value of L is 0, m की value क्या होगी? You cannot write minus 0, 0 plus 0. Does it have any significance? No. So it has only one value 0, means it has only one orbital. 0 का मतलब ये नहीं है कि कुछ भी नहीं है, कन्वेंशन हमने असाइन किए 0 तो एक ऑर्बिटल है. देन अगर हम करें L की वैल्यू 1, दैट इज P सबशेल, L 0 है तो S सबशेल. अब यहाँ पे क्या वैल्यूज हो सकती है? We can write minus 1, then 0, then plus 1. So total 3 values are there. So we represent it by 3 orbitals. Similarly, if L is 2, that is D subshell is there. For 2, it can have minus 2, minus 1, 0, plus 1, plus 2. That is total 5 orbitals are there. So अब अगर हम देखें कि if L value of L is 2, तो M की कितनी वैल्यूज हुई? अगर हम इस फॉर्मूला में पुट करें 2L plus 1, that is 5. So 1, 2, 3, 4 and 5 values are there. Similarly, अगर हम L value 3 लें तो कितनी वैल्यूज होनी चाहिए M की? That is 2 into 3 plus 1, that is 7. So it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So there are 7 orbitals in it. और अब जब हम different directions की बात करते हैं, so Schrödinger has given these that orbitals, they are in the different direction. Three dimension means x, y and z axis. So you can see in this, like different directions are given. M1 minus 1 is there. So different directions, px, py, pz, we convention, we assign them. So if we state like if L is equal to 1, M has minus 1, 0, plus 1 value. It is a P subshell. So 0 के लिए we assign PZ in Z direction, this one X direction and this one is Y direction. So we say like if it is 2px, so for 2px, value of n is 2, that is in second shell. L is 1, that is p सब shell. और x है तो मीन्स की जो ऑर्बिटल है वो कौन सी डायरेक्शन में है, दैट इज x एक्सिस +1 value. So in this way we assign this. Similarly for d orbital we can say for L is equal to 2, m can have values -2, -1, 0, +1, +2. Now in this 0 value is dz square and this 1 value is for d. So for -1 and +1 we assign the value dxz and dyz, means any value we can assign to it. Similarly for this one, dxy, dx square, y square. Any value we can assign plus out of this. We can write like dxy, we can assign +-2. Similarly for dx square, y square, +-2. It can be assigned plus value or minus value. So like if it is given that like 4d x square y square. So write the quantum numbers for this. So this is like n is equal to 4, that is in fourth shell, and L is equal to 2, that is in d subshell, and m is equal to +-2 is there. Then another point is there that each orbital can have maximum of 2 electrons. So if there are 3 orbitals, like in p subshell, there are 3 orbitals, that is total 6 electrons can be there in p subshell. Then last quantum number is spin quantum number. It is represented by ms. Like if electron is moving in a atom in orbital around the nucleus, so obviously magnetic field is there. It is moving around its axis, also around the orbit or nucleus also. So it will have some spin in that. So just we assign 2 values to it, +½ or -½ +½ means that electron is moving in a clockwise direction, and -½ means it is moving in a anti-clockwise direction. So these are the 4 quantum numbers with which we can represent specify the position, shape, orientation of the electron. If it is given, like question any can be there, that if n is equal to 3, L is equal to 1 and m is equal to -1. So assign the position to the electron. So in third shell, in p subshell, and in x orbital it is. So this is how we designate, or vice versa also can be there. Like if I write 4p, that is it is in fourth shell and it can be in first in p subshell, or because here nothing designation is written here whether it is in px, py or pz, we can assume any value it can be. -1 +1 or 0 can be there. Okay. So related to this there are principles. One is Aufbau principle, and second one is Hund's rule, and third is Pauli's exclusion principle. So which are used to write the electronic configuration of an atom. So I hope this much topic is clear to you. Thank you.